Hello, everyone, and welcome to our next CME Palooza session. I'm Derek Warnick. I'm going to get right to my intro slides. Here we go. So this is our 11 a.m. Eastern Time session. Shiny Outcomes People. This session is sponsored by Peer Audience, and our moderator for today is Jason. Oh, Jason, say your last name for me. I always say it wrong.
Oliveri.
There we go. Director of Outcomes at MedIQ. And everyone's favorite part of the session, the reading of our sponsors. So our gold sponsors, big thank you to them, Daiichi Sankyo, PER, and Academic CME. And our silver sponsors, Peer Audience, Medscape Education, Clinical Care Options, and PCE. And our bronze sponsors, big thanks to them, PVI, Catalyst Medical Education, Semiology, ACHL, Vindico Medical Education, Paradigm, Postgraduate Institute for Medicine, Global Education Group, CE Outcomes, Integrity Continuing Education, RMEI, Helio CME, Infograph Ed, Med Learning Group, Primary Care Network, Prova Education, and Red Med Ed. I know, keeps going on. Yeah. You know, Jason, you could give an individual sponsorship and we would list your name on here alone. We'll look into that next time. Two ways to ask questions. You can use the Peer Audience text line to send in a question, 267-6660-CME, or you can tweet your question using the CME Palooza hashtag. As always, I'll be monitoring both of those and giving your questions to these guys as I can. And then last thing for me, speaker disclosure slide, all opinions, discussions, and or conclusions expressed are those of our panelists and do not represent an endorsement by or position of their employer, its parent company, or affiliates. And with that, I'm going to turn things over to Jason.
Hello. So Derek W., are you going to put the first slide up or is it up and I just can't see it?
Yes, hold on. Sorry, I forgot you're going right into those. I got it.
We're all about business here. Okay.
There we go.
We are surrounded by amazing products. If you look at what's on the screen right now, I'm going to say this is probably some of the most transformational things we've ever delivered to consumers in the last 20 to 30 years. And while no one would argue with me, we do have to admit that each of these products, although marvels, do come with a few limitations. The shake weight, for example, the perfect marriage of concept to engineering, really a quite flawless seeming product. I'm told it was inspiration for the iPhone. Can't verify that. However, we do have to admit that some of the health benefits of using the shake weight have been a little bit dispiriting. Granted, phase 3 trial data is yet to be released, but the results are not exactly what we expected. This brings to mind outcomes assessment. Thinking about assessing the effect on the minds and practices of clinicians as a result of participating in education, it's just chock full of amazing products. Think about, say, the 90-day post-activity follow-up survey. It seems quite perfect, and physicians love to fill them out. We get amazing data from them, but there may be some challenges to those products. Let's look at the next slide. So it's with that humble understanding in mind that this group of panelists assembled in Gatlinburg, Tennessee, a few months back. Now, this is an auspicious location, of course, because it's where they originally split the atom or sold the most per capita Snuggies. Either way, it's a place where minds go to meet. And our goal here was to identify what are like some of the key products in outcomes assessment, and not just so much what are the wonders of it, of which there are multitudes, but what are some of the challenges in these things? And the idea here then was to take these products and through a platform like CME Palooza, which reaches globally hundreds and hundreds of thousands of people from Auckland to New York to Paris, and provide them with this information so that CME providers across this universe can now apply them in their practice, wield them in a way that's most effective, understanding their strengths and their limitations. So let's look at some of those products. So we're going to talk about 4 products today. National Board of Medical Examiner guidelines. What are they and why do we need them? We're going to look at matched data, looking at pre-post tests. What if we do it? What if we don't? We're going to talk about effect size. Is it an effect or an affect? In so much as is it really measuring what people think it's measuring, or is it more wishful thinking? And lastly, we're going to look at cost effectiveness. Can we really measure the effectiveness of what we do with nickels and dimes? Let's go on to the next slide and look at our shiny outcomes people panel. So what you're looking at here are some of the deepest thinkers in the outcome space globally. Each and every one of these people was vetted with criminal background checks, 3 years of IRS audits, Miggs-Bryer personality exams, and we also did a survey of favorite album, color, and mythical creature. And the reason why we do this is so that you as the audience can feel confident that the information presented herein is unassailable and something you could use 100% with confidence in your own practice. We'll be starting off today with Tony Gage, AKA the Kansas City Kid. He's director, we're all directors of something or other, aren't we? Strategy and analytics at Practicing Clinicians Exchange. Tony, I had here on my record that your favorite mythical creature was the Loch Ness Monster. Is that correct?
As the father of two girls that are 7 and 5, it's actually the unicorn.
Unicorn. Oh, let me correct that.
Yeah.
So, okay. Well, that shouldn't affect your presentation. And following, we have Katie Lucero, Director of Outcomes and Insights at Medscape. Katie, I have your favorite album as Something in the Water with from Pokey Lafarge. Is that correct?
Maybe in a past life.
Okay.
I would say, yeah. I don't know, Jason. We haven't known each other that long.
I'm a little concerned that my record keeping isn't perfect, but I think Derek's going to bring us home. So we have Derek Dietz, President of Metrics for Learning. I have your favorite color is razzmatazz. Is that correct?
Oh, you bet.
Thank you. Thank you. Okay.
Blue. Yeah. It's good.
Okay, so we can be confident in your presentation. I'm a little concerned about Katie's and Tony's. Got it. All right, with that, I'm going to move us on into the actual presentation part. Tony's going to talk to us about National Board of Medical Examiner guidelines. What are they? How do they work? And why should we potentially use them in our own practice? Tony?
Hey, I'm going to jump in real quick if I may. Can I ask when you guys mute yourself when the other person is talking? Just getting a little bit of background noise, so I think it'll make it better if everyone is muted other than whoever is talking.
Yes.
Great, thanks. Take it away, Tony.
All right. So, yeah, we can just move on to the first slide. So when we're creating measurement tools for CME activities, you can go to the next one, actually. Sorry. We're ultimately constructing a ruler. So we're trying to measure how much of some psychological or behavioral construct that a learner possesses. So in CME measurement, we're talking about satisfaction, knowledge, confidence, ability, confidence, or attitudes about something in particular. We give people scores on assessments or tests, and we interpret those scores or changes in those scores to represent effectiveness in education, depending on our research design. So the detail or precision with which we're able to assign these scores to the learners, depends on a lot of different characteristics of our measurement tools. Some of these things are the number of questions that our scales have, the quality of work that went into the definition of what we're measuring. So just as good education is dependent on quality needs assessment and gap analysis, same thing goes for good measurement. And then also the way in which we collect the data can have impacts on what those scores wind up looking like and how good or bad maybe they are. But another critical area for constructing quality measurement is the process with which we write the questions themselves. So let's go to the next slide. Because unfortunately, we often make mistakes. You know, we kind of know what these flaws are. We have long and complicated options or scenarios. We maybe use negatively phrased stems. There's this long laundry list of common flaws, and this doesn't even list all of them out. But what all of these flaws do is they introduce something called construct irrelevant variance. And so what this means is, you know, we want our questions to elicit responses that are based on that content or construct we're trying to measure. But when we commit these flaws with questions, we change the difficulty of the question, and the reason that it's harder or easier to answer is unrelated to that core construct we're trying to measure in the first place. So it might be measuring something like reading comprehension, or especially, you know, if we have long drawn out scenarios, but we only allow people 10 seconds to answer them, we might be measuring processing speed instead of, you know, the actual medical content that we want to know whether people have any understanding of or not. So, you know, that's what makes the task of measuring educational outcomes particularly challenging. But I do have a little bit of good news if we move to the next slide, or at least some comfort to offer you. You know, there isn't a teacher, a professor, a testing company out there that doesn't make these mistakes, right? So everyone makes them, and we kind of just have to have us avoid them as much as possible. So it's one of the reasons that assessments that are created to make more critical decisions, like a credentialing exam, it's why they have so many more questions on those exams, is that they actually have they're able to ignore questions that maybe aren't performing very well. They don't let those questions contribute to scores. We don't have that luxury in CME, but it doesn't mean, you know, that we just can ignore kind of, you know, these best practices when it comes to writing our questions. So the next slide lists out kind of the core criteria or guidelines that the National Board of Medical Examiners lays out in their documentation. We want to make sure we're focused on one important concept at a time. We want to assess application of knowledge, be focused, closed, clear, be as concise as possible, and make sure we're getting to the core of the content that we're trying to measure. All options should be homogeneous and plausible. We don't want to throw in even like options that are just kind of jokes, can kind of, you know, some people will answer them in trying to be funny, and then it kind of makes the measurement of the actual content a little bit more murky. Also, having someone be able to review our questions can be really helpful. And I don't even think it necessarily needs to be an expert, because I know everyone's kind of strapped for having, you know, content experts be able to review. But oftentimes for some of the flaws that we're talking about, it's almost better to have a non-expert look at these questions, because, you know, if I, as a novice, am able to detect what I think the correct answer is just based on using some simple heuristics, it might suggest that the question needs to be looked at a little bit more and kind of improved. So I did have an asterisk that I added on the second one. I do think, you know, almost always we're looking in CME at, you know, application of knowledge. However, really the advice here, I think, from a measurement perspective is make sure you're writing questions to the cognitive level that you've defined, right? So if your education is really, truly only interested in knowledge or awareness, it's probably okay to have knowledge questions. But if you're looking at, you know, application performance, you know, we obviously want to write questions that are related to those sorts of cognitive levels. All right, so the next slide. What does all of this buy us? You know, from a psychometric point of view, we talk about things like reliability and validity. The more we follow these guidelines, the more likely we are to construct scales that are reliable and valid. The challenge is those terms are kind of thrown around without a whole lot of understanding or like agreement on exactly what's good or bad. But ultimately, practically speaking, the better we do at following these sorts of guidelines, the more precise measurement we have with our educational tools. So What that means is we have better ability to detect differences between groups that truly exist in the population. If we wind up using our measures in predictive models, those are more likely to get positive results. You might have a really great theoretical model as to how, education is going to predict some sort of outcome, and you run the data and nothing comes out the way you expected, but maybe it's because the measures that we used in the first place weren't very reliable. And if you're giving feedback to learners, the feedback they're going to get is going to be a lot more accurate. So at the end of the day, better measurement results in positives for all the stakeholders in the CME space, not just us outcomes folks.
So, Tony, I feel like that's the end of your part talking about these guidelines. And what we want to do with this part now, that's correct, right?
Yeah.
So what we want to do now kind of as a panel, take in about what you said and think about what some of the kind of limitations or concerns might be. So the first thing that jumps to my mind in sort of the most generic global sense of things is if we're, publishing, sharing these guidelines and incorporating them into our practice, how bulletproof does this make our questionnaires? Is this what's the marginal gain here from I'm creating questions with just my content people using whatever sort of rubrics in their head. Now I'm using these principles. Obviously there's a leap there. How close does that get me to what we would call, perfect?
If you're looking for a number, it's kind of hard to answer that. I think it gets. I've worked in testing organizations in the past that did standardized tests for nursing schools and admissions type tests for nursing schools. And I'll tell you, so we were one of those companies that had the luxury of what's called pre-testing our questions. So we'd put a certain number of questions on a test that weren't even scored to see how they performed with the target audience. And even with the amount of effort we put into development, multiple reviews, following all of these guidelines, there were still oftentimes, 20 to 30% of our questions that we wound up just having to edit later or we never used them as a scored question. So I guess, you could get to a point where you're getting 80 or 90% of your questions are, really, really good and functioning well, but there's still going to be some that slip through. Does that answer it?
What I'm trying to make sure I'm not muted here. What I'm trying to get at here is how much of this is, is still an iterative process. How much of it is an art, and how much of it is a science. So if we start following these kind of guidelines, at the end of the day, we're improving our practice, but there's still many, many steps beyond that of improvement. So it's a pathway to writing better questions. It's not an endpoint.
Definitely. And I think, like I said, sort of at the beginning too, this is just one piece of what makes a quality measurement instrument, right? We could do all of these things perfectly. And, we might mess up on the data collection piece, or we maybe didn't define our construct very well. So the questions we wrote weren't very targeted. I think it's kind of the challenge of anytime you're creating a test is kind of balancing, the resources you have and doing what you can to make the best tool possible.
Derek, Katie, do you guys have any experience using these in your practice? Any thoughts on maybe some concerns about using these in your practice?
You bet. Have a lot, and the most recent version of these guidelines, I think, is much better than the previous one. So I had a chance to look at that and hadn't seen the newest one. I think 2016 is when it was published, and I think it's really good and helpful. Previous version, a couple hundred pages, I can't remember. It was a monster. This one is more succinct and to the point. I like it. Here are some of the things that I think we need to consider in our context. So continuing education for the health professions. there's a really good set of rules. If you can distill that down into like 10 rules maybe that you have on a checklist, that are the top ones that you most commonly see an issue with, this is what I do. I use a checklist. If there's a problem when I review a question, I say this breaks rule number 5, and I suggest an alternative. And that's a way to go. Another thing to be concerned about is, what's the format or the medium that you're using for your education? In a live setting, with a large group of people, with ARS questions up on the screen, you really ought to be asking not easier, but simpler questions, shorter questions, in my opinion. And when you're online, you may have a better opportunity to do something that's a little longer, where a case vignette would be even more productive. But there's some medium related conditions to consider. But overall, I really like this set, but I prefer to simplify it as best I can.
I like the suggestions. Thank you. So Katie, you're going to talk, and sorry, Tony, if you want to respond to that really quickly, I'll give you a second here. But Katie, you're going to talk to us next about paired versus aggregate data. In lieu of Tony having one thing he wants to add there or not, if you have anything you wanted to say about NBME to sort of kick off your portion, please do.
All right, so hi everyone. So my topic is about paired data. So next slide, please. So this is in the context of pre-post questions, which is a really good kind of bounce off topic from what Tony just talked about. If you don't have well-written questions, then how good are your data really? Next slide, please. So in my opinion, I think most things are better in pairs. I don't know if twins are better, kids are better in pairs coming out as twins. I am not a parent of multiple, so I like my one. But I would say candy is definitely better in pairs. And being kind of a research evaluator, I think that data is better in pairs too. But let's back up a second. Let's go to the next slide and think about, what is aggregate? I often hear within our industry this idea of aggregate versus paired. And from my perspective, keep going on the cue, please. Aggregate is really a summary of statistics or summary statistics from many different observations. Next. So from this one summary statistic using aggregate, or an aggregate statistic is % correct at pre and post. And that's kind of the most common way that I see us presenting outcomes. So really, I think as an industry, when we say aggregate, we really mean using all responses. So do we use everyone who answers the question, or do we only use people with complete data? And that's the paired aspect. Next slide, please. So visually, we have, what is all responses? What is paired? Next, yes, and next. So all responses, you're taking everyone's answer to the questions available. So you have some people who answer pre and don't answer post. You have some people who answer post and don't answer pre. And then you have this group who answer both pre and post. And so that's paired. You have a pre and a post value for everyone in your sample. Next, please. And so they have complete data. So the reason I think paired is really the best route to go is, one, you are able to use statistical tests that offer greater precision and reduced measurement error. So you're using basically, it's like doing analysis on longitudinal data. So you have a pre and post for everyone. And so you're able to use like a McNamara's or a paired samples t-test as opposed to an independent samples t-test or a chi-square. And these are just statistical tests that allow you to basically utilize your sample better. So if you had a sample of 30 with paired data versus a sample with 30 with unpaired data, you would be more likely to achieve statistical significance if the effects were the same using the paired tests, because you have more power and more precision. you're able to provide more aggregate statistics to describe your data, to describe your outcomes. So the first is the obvious percent correct pre and post, which we all are familiar with. The next is you're able to summarize your data by question and what happens longitudinally to your participants. Are they improving, meaning that they didn't know the information at pre and then they knew it at post? Are they reinforced, meaning they knew it at pre and they knew it at post? Or are they needing education still, meaning they got confused, or we think they got confused, that they knew it at pre and didn't know it at post, or they didn't know it at both pre and post? And then you're also able to have more statistics on your overall data. Next cue, please. So you can say the percent of people who improved, meaning they got at least one more question correctly. So they gained something positive from the education. And then one could argue also that if you're reinforced, you are gaining something positive from the education, meaning you're confirming something that you're already doing is still correct. And so you can measure that. What did I know at pre, and did I know the same thing at post? And what was that percentage of information I knew? And then you can also talk about the people who had that reduction in a score or left education knowing none of the answers, none of the questions. And then finally, you know your sample bias when you're using complete data. It's basically those who are more likely to complete all the questions. Now we can talk probably ad nauseum about what that really means and who those people are. But when you're using people with or sample with incomplete data, you really don't know why they didn't answer all the questions. It could be because they came to the activity, they answered the pre-questions, and they left because they realized they knew the information. Or they got them all wrong at pre and said, this doesn't really apply to me, or it made them uncomfortable, and they left. But oftentimes I do see an inflation at your pre, suggesting that people are coming in, they know the information, and then they leave because they realize, hey, I don't really need this education because I knew the information. Next slide, please. So I just wanted to show a quick example. The proof is in our paired pudding here. This is results from a program that had 3 questions pre, 3 questions post, and I can barely see my own slide because I'm on my cell phone. There's an 8% relative improvement from pre to post. Now, none of us would be super excited if we saw that result, probably. But by using the paired data, we're able to get more aggregate statistics. And one of those is the percent who answered at least one more question correctly. So we saw an improvement. 23% of the participants improved their knowledge and competence based on the types of questions we asked as a result of participating in the activity. So I think most people would agree, you have potentially a better story with this 23% who improved their knowledge and competence as opposed to an 8% relative improvement. So that is why I would argue for using paired data.
Thank you, Katie. So I'll kick off the panel part of the discussion here with a reference to a paper that came out. I don't remember the year. I remember it was in JSEP, and I remember it was within the last 5 to 10, let's say, where they looked at, I don't know if it was just live or enduring or some mixed, but they were trying to get at this paired versus aggregate question and see, does it really matter? And I know they presented at the Alliance about it. And, it felt like with most things, somebody did a paper on it, they did a presentation on it, and they said, in our findings, the message I was left with, it wasn't substantive, whichever approach you used. And it felt like it kind of put a pin in it. But we didn't really get into, well, what was the study design? What are the limitations? How far can we really take this conclusion? I don't know if you have any thoughts about that that you'd like to add.
Yeah. So I did read that paper, and I want to say that I think the primary outcome for that paper was the percent correct pre and post. So it's using the standard statistics that we're used to presenting and calculating. And so I've done some of my own analysis on that very topic. And I would say that their conclusion I was replicating essentially that the percent difference in using aggregate versus, or not aggregate, all responses versus paired in reporting those statistics is maybe like 5% on average difference. But when you use paired, you're able to have that precision, and you're able to provide more summary statistics, more aggregate statistics to describe your data and talk about the impact. So it's like going to a restaurant with, 2 menu items or 1 menu item versus a restaurant with 5 menu items. So it just helps you be able to craft a better story around your outcomes to use the paired data.
Okay, thank you. Tony or Derek? Tony, I know this is something you've dealt with in your practice. Do you have any thoughts on?
I mean, I guess I think that, the question is really, what arguments are you trying to make, or what kind of story you're trying to tell, right? Like when it comes down to it, in most cases, I think pre-post, especially pre-post, I think maybe when you're looking at follow-up data because of the sampling issues there, and that article that you referenced, Jason, didn't really look at follow-up data. But so if we're just talking about pre-post, I do think the decision consistency is there, whether you're using aggregate or paired, right? You tend to get the same conclusions statistically. Really, the biggest advantages for paired data come from a lot of what Katie was talking about when it comes to the different ways you can look at the data then, and kind of fill out the story beyond there was a statistical difference. Well, we can actually look a little bit more detail to kind of how people changed over time. I can provide a more, an interesting story, let's say.
Yeah, and my comment would be that a paired approach is just totally unrealistic for many, I don't know how many, but a lot of CME settings. I mean, there's organizations that have very few people that come to their sessions or their activities in a live setting, and there's no way they can do paired. Whereas when you got thousands of people or hundreds of people participating in a format like online, where the pairing of pre and post seems to be much higher than a live setting, paired works great. And I love paired because not only can I do some of the additional things that you mentioned, but I can do crosstabs to understand the characteristics of the people who change, and I can look at differences when I have, questions that have scales. How much of a change was there, and how many people are seen per week, patients per week, by those people who increased their frequency, for instance, or their confidence in their ability to do something. But I do like one of the comments that was made that you like to use paired data, but when it comes to needs assessment, you commonly will use all of your pre-data to help you. You got a larger N. I like that too.
Yeah, I would definitely agree with that. Derek W., you had a question for Katie?
Yes, question came in on our peer audience text line, specifically for Katie. Is it valuable to report both aggregate and paired? And if so, how do you effectively do so? What kind of conclusions can you draw from reporting both?
I think it's valuable if you're the one producing the outcomes to take a look. I've seen like at just a question level using aggregate versus paired, or sorry, I keep saying aggregate because that's what you use, but it's really just all responses. You might be able to make some conclusions about what the people were like who were coming to the activity. So you could say you had 200 at pre and 100 at post, and you had like 50% was the pre and 62% was the post on the all responses. And then on the paired, you had 45% was the pre and 63% was the post. You could say that knowing at the pre, that was a little inflated for the all responders, all comers, that potentially those folks, like I was saying earlier, knew the information better. And so the education may not have been as applicable to them, or they didn't perceive it as applicable to them. So you're understanding more about the sweet spot of who to target in the future. So to answer the question, there's value in looking at the data that way, I think. I don't know if there's necessarily value in going back to, say, it's a supported activity and you're going back to the supporter and talking about this, unless you're using that information to inform the next activity you're proposing.
So I have one more that I want to ask on this, and then we can move on unless somebody else has something to add. But Katie, you brought up sample bias a little bit, and whether we're using aggregate or paired, we'll peek behind the curtain. At least what I've experienced over the last 15 years, no matter what, there's a lot of people who don't respond one way or the other. So how concerned do we need to be about sort of sample bias in general? And I kind of opened this up to the group because I'm sure you all have experience with this, as far as what about the community that's just not responding to my instrument at all? And how does this influence my interpretation of my pre-post data, regardless of whether it's aggregate or paired?
That's, I think, a really good question, and one that I've pondered a lot since being in this industry for the last 2 years. I'll say that I've looked at patient, we cross-match our data sometimes with IQVIA. And so I've looked at what's the difference between learners who don't complete outcomes versus learners who do, in their number of patient encounters in the disease state of interest. And there wasn't a difference there. I looked at their news consumption on Medscape also. There wasn't a difference there. They were both just as interested in news. So potentially the same relevance, right, of the program. But the people who responded to the outcomes were consuming like 3 times more CME than those who weren't. So it suggests to me that there's some people that just really like CME and assessment. And they're the ones who are more likely to participate. And something else that I found interesting is, you know, and others may have too, when we work with psychiatrists, they're more likely to complete. And they're more likely to do your follow-up surveys. And I think it's because of the field that they come from. It's strong in assessment. And so they're more likely to do it. So I think it's more of a personality thing than it is a real practice thing. Others?
Yeah, I think the other aspect is, especially with like live in-person ARS data where it's easy to just not respond, in our setting, there isn't really a whole lot of incentive to respond, you know, as compared to a higher stakes testing environment where, like, I know that if I don't respond, I'm not getting credit for that question. So I might as well guess. I do think that there's a lot of interesting research to be done out there about what is really going on with the missing data. But then also on the flip side, if you're online and you're forcing people to respond, you know, you have to realize that you're introducing a lot of guessing behaviors that, you know, also impact the data you're seeing. You know, and I guess the only other, parting comment that I would have about this topic in general, Derek, you were saying, you know, sometimes it's just not feasible. And I think one thing that we should get away from is arguments over statistical methods being like correct or incorrect all the time, because I think really they're ultimately tools in your toolbox. And, you know, sometimes you may not be able to execute a paired sample, and, you know, other times you will be able to, and that's okay. It's more important to know kind of what the trade-offs are of each method.
Well said, thank you. So, Derek Dietz, I am promising you right now that I'm not going to go ad nauseum and stick you with just 2 minutes at the end of this thing. So don't worry, we're going to move on to effect size, and I'm going to try to be expeditious. But we can go on to the very first slide here, or the next slide, excuse me, where we're going to introduce, hello, my name is effect size. So effect size is awesome, and I'll give you 2 reasons why. Number one, we've been talking a lot just in this last segment about pre-post assessments, whether it's paired, whether it's aggregate, whatever it is, you're going to have more than one question. You might have 2, you might have 4, you might have 8, however many it is, it's variable across the activity and the provider, but you're going to have multiple questions at the end of the day. And you can take that information, and historically, the way we've presented that back to the people who support our education is to go through slide by slide and say, you know, here's our first question, here's the learning objective it ties to, and here was the change. And you get through however many of those in a presentation. And then at the end, let's say it was 4, you get into this very sort of squishy subjective area where now the supporter's sort of looking at you and you're waiting for them to say, well, like, I like this or I don't. And maybe they liked it because they liked one question, the way it moved. Or maybe they didn't like it because there was one question that was really important that didn't go the right way, but the other 3 were really big changes. And it's left to this very, personal opinion realm. What effect size can do now in that particular scenario is it can take the change across all of the questions and consider it in a single metric now. So you're really creating a test score for what happened pre and what happened post, not what happened on an individual question level. That data is still valuable if you want to go through and look at it, but now you're coming up with an overall, here's how they did in this education, and here's the magnitude of change. And that's a much less subjective understanding of what the effect was. So that's one reason why this is really groovy. The second thing now is effect size is a relative measure. So if we go through that process at the end of the day, and I say, okay, well, here's 4 questions, and here's the effect size for it, and that number is 0.43. Well, 0.43 by itself is meaningless because effect size is a relative measure. It has to be compared to something else to give you context around it. So what you're actually doing now here is repeatedly throughout your activities calculating an effect size. And because of the standardized format now, you can look at change. Many caveats here, and we'll get into some of those. One of those caveats is you're using the same assessment methodology in each case when you're calculating effect size. But now you can say, oh, I've done this annual conference because it's annual every year for, say, 10 years, and I've come up with an effect size. Now I can see how that effect size for the 2020 activity compares to, say, the last 9 years. Is there a trend there? Is it going up? Is it going down? Is it staying flat? What does that look like over time? So this gives you the power now to look at things in a programmatic way, which is a really groovy thing to do. Now, the other part of this, the third thing that makes this really great, is it sounds hard. It sounds technical, but it's super wicked easy to calculate. We'll go to the next slide, and I'll show you very quickly kind of how this thing works. Now, I will say there are presentations on CME Palooza that walk through in a very menu-based way, recipe way, how to calculate effect size. And I'd say go to the outcomes section of CME Palooza, and you'll find it there. But in general, I've condensed it down to this sort of magical algorithm on the screen here. What you're doing here is you're taking your pre-post questions. There's one of them going into the pot. You're sort of mixing them all together, and then you're pulling out the mean pre-score and post-test score and a standard deviation for both of those as well. You've got your handy-dandy robot now takes those, the mu and the sigma, which is right there in the conveyor belt, and you're plugging them into a calculator. These calculators are free online. If you can calculate a mean pre-test score, or mean score and a standard deviation for your pre and post data using Excel, so I'm sure that's accessible to just about anybody listening to this call. You just type in effect size calculator online, you'll find many of them that are free. Just plug that data in, and it's going to kick out your Cohen's D. That's what's coming out of the end of the conveyor belt and going into the packaging truck. That D now has many different effect size types. Cohen's D is one we use fairly consistently in CME. So this is the one we're talking about right here. And there you get that number. So D equals 0.83. You can stand up in front of everybody and say CME works. As long as you're giving them that relative scale to see what a D 0.83 looks like, or what D equals 0.83 actually means, excuse me. I'll show you that in the next slide. Okay, so here's an example of a way you could report this kind of information. So we've got some benchmarks. Now, Cohen very cautiously gave some initial benchmarks. He said, if you're going to start measuring Cohen's D in an industry, you can consider 0.2, 0.5, and 0.8 as benchmarks. 0.2 being low, 0.8 being outstanding, and 0.5 being somewhere in the middle. Then the caution was, of course, that you have to repeatedly measure and level set in your own industry to figure out what these values should actually be. But here's a starting point. So we have a bar on the right side of the screen there that's 0 to 1, which is sort of what we'll call our expected range. We've got our Cohen's benchmarks, small a 0.2, large a 0.8. And we want to see where our effect size falls for a certain activity. And for this hypothetical example, we've got that marked off on the bar. So we can see, according to the preliminary benchmark, it suggests we did a good job. We had a large effect. Now, if we've been repeatedly measuring, say over the past X number of years, we can look at like activities and we could come up with an expected range for, say, internet-based CME. One thing we do in our group is we've been doing it for multiple years, and we've come up with sort of an expected range now, which gives us sort of a red light, green light, yellow light area. That's that bracketed area right there, which says, looking at the last 3 years, this is typically where our effect size fall. So if our effect size for a given activity, where does it fall in relation to those brackets? If it's above it, we probably did a pretty decent job and we could be happy. If it's in the middle, we did as expected. And if it's below that, this is an activity for concern. And now we want to dive deeper into the data and figure out kind of, what do we do wrong here? What can we improve for the future? Having effect size gives us that sort of instant assessment point to allow us to dissect, how do we need to think about this activity as far as taking it forward? Do we repeat, or do we just, or do we think about room for improvement? So we'll go to the next slide. I'm going to be really quick about this because I've already talked longer than I should have. In a programmatic standpoint.
Hold on, Jason. Hold on. Sorry. Yeah, I lost. We're back.
I get that minute back. In a programmatic standpoint now, I could look at, say, all my live and enduring over a 3-year period of time or whatever period of time and see how it's tracking. And now also in here, I've got references to the literature, because the literature will report effect sizes from meta-analyses as well. And I can see how I'm faring against this. So from a program standpoint, how am I doing overall? Effect size empowers you to do exactly that. Let's go to the next slide. So concerns. There's a lot of concerns here that potentially erase all of the wonders of everything I just showed you in the previous ones. One, quality assessments. Not all questions are created equal. Tony walked us through that pretty well. Number of assessments. How many questions do you need to calculate an effect size? Is it 4? Is it 6? Is it 8? Is it 2? I don't know. Nobody knows. What if I use 4 and Medscape uses 8? Can we compare effect sizes? Probably not. Response. Did a representative sample of participants respond? We talked about response bias concerns or sample bias concerns with Katie's presentation. Study design. If I'm doing all pre-post assessments and someone else is doing post versus control assessments, can we compare those effect sizes? Most likely not in that case either. And lastly, benchmarks. So heterogeneity and publication bias and peer review. You have to compare apples to apples, like to like. If we talked about with those last examples, if I'm using one approach and somebody else is using another approach for effect size calculation, that's heterogeneity. Those are not necessarily comparable. Also, publication bias, we tend to only publish good news. That inflates what effect size actually is. So if you're comparing your data to published literature, odds are that that benchmark is going to be higher than what would happen in natural practice and is maybe not a fair comparison. So we'll go on to the, that's it for my part. If anybody has any questions, please ask them, and I'll try to respond quickly and just chew up a minute or two, and then give Derek a chance to talk about what I think is really important, some cost effectiveness.
Jason, this is what we can do. We'll keep moving forward. When we get to be about 11:57, I'm going to do the wrap-up slides. But then after that, we can keep going, and we'll answer some of the questions that come in. Scott might bump us from the live, but it'll be on the recorded version anyway.
Thank you.
Okay.
Great, thank you. I was beginning to wonder, Jason, if you were calling us shiny because of my forehead right now. But what I'm going to talk about really is trying to understand better what the economic impact of our education is. So what are the costs that are incurred because our learners do something that is evidence-based and we're encouraging them to do, that's better care? So what are the costs to the system for that, direct costs? And then are there cost savings if they perform differently or better? Next slide. So I'm going to share a couple of studies with you. And the first one I was involved with, it was a national scope educational initiative that had multi-components done by Vindico Medical Education, supported by Gilead, focused on increasing HIV testing, and then the use of PrEP guidelines, pre-exposure prophylaxis guidelines. And so what were the direct costs if your education was successful, given how you might normally measure it? How many patients are offered a test, an HIV test, identified as positive or negative, and then were they treated and complete treatment? And so we want to understand the costs of that. So advance. So to build a model to answer these questions, you have to have parameters. And some of those came from our learners. Of course, we had 4,500 plus learners. And then we took some of the measures that you typically use for outcomes and gathered that percentages of patients that they see that are high risk for HIV, how many patients they see per week or per month. And then what percent of them newly plan to engage in the behaviors or the performance change that you want them to. And then, of course, there's the complexities of what patients do when you offer them a test or you offer them treatment. Do they accept the test? And then for those who are tested, what percent end up being positive or negative? And then how many accept treatment and follow through on their treatment? Next slide. So what we came up with, and this was presented as a poster, patient impact after 1 year. This is our estimated number of patients newly offered an HIV test because of the CME. That's 135,000. That's a lot of patients. 54,000 accepting the test. Next. So out of those, how many ended up being HIV positive? 163, 49 of which accepted the therapy. And if you treat those 49 for a year, you've got $1.2 million. Holy smokes. Then what about those who are HIV negative who are potential candidates for PrEP to prevent the transmission of HIV? So 54,000 of them, 3,900 which accept the PrEP, and a year's worth of treatment for those 3,900, $92 million. Have we thought about this before? What costs are the healthcare system incurring because of our education? Here we're talking an estimate of $93 million. If it was a half of that or a quarter of that, do we even understand this? But this isn't the whole picture. Next slide. Did we save any costs because of the education? And this was a different study, and with support from Bristol Myers Squibb and Semiology did the work and published this in CE Measure. So their focus was on earlier HIV testing and earlier treatment didn't have anything to do with pre-exposure prophylaxis, but they wanted to know, did we save anything by our learners doing earlier testing and informing patients of their serostatus, and then treatment earlier? And their model didn't look at the costs per se of care, but more about what was saved. So by reducing transmission, what did you save? And they have their set of parameters as are shown there. Their model estimated annually 394 HIV cases prevented and a mean direct cost savings of 10.7 million. So neither of these studies perhaps answered all of our questions about costs, but I'm convinced in our community we really ought to be thinking more and learning about this. I'm not making a value judgment about whether spending $43 million because of CME is bad. I'm just saying we need to understand the implications. Your thoughts?
Okay,
So-
I'm gonna jump in here real quick and do our ending things, and then we can keep going. So give me 1 minute. So to wrap up here, and then I'm gonna let them keep going with questions. But anyway. Our survey that I've been telling everyone to take, I'm told the link is broke. So perfect for the outcome session that I talk about a broken link for the survey. I'll fix that when we're done. We'll all survive if people don't take the survey. And then to view the next session, Scott's going to bump us out of here and put up his code for the video for the next session. So all you have to do is the same thing as usual and refresh. We're going to keep going for a couple extra minutes so they can answer some questions. All the questions will be on the archive version, which I'll have up on the website fairly soon afterwards. But that is it for my part. So Scott, if you're listening, you can go ahead and bump us out. I'm going to take us back to here. And Jason, you can take it away again. And I do have one question that I can give you verbally whenever you're ready for it.
Okay, so I don't think we need to take too much more time on the line here. I apologize for running a wee bit long. But I love, Derek, the whole idea. I'm thinking of butterfly effect when you're talking about CME, and it's one of the, my little CME activity flaps its wings and, Chattanooga, Tennessee, what happens, downstream. And I don't think that's something that we really think about, the interconnectivity of it all. My question is in that, and in looking at a little bit of cost effectiveness research in CME, which I'll say is developing at best, it's taking those cost models, and Katie's going to jump in here. She's got a lot of experience, which are very sophisticated and can do awesome things on that end. But it's, again, the initial effect of the CME itself. It's how do you truly quantify that in a way that the cost effectiveness makes sense. So it's like I can figure out all the nickels and dimes of how much these treatments cost and that kind of stuff. But getting to that from what the actual effect of the CME was, that feels a little squishy to me.
It is squishy. So as you saw, it went by quickly, but the subjective information or data that we're using to fit into the model are self-reported intention to change behavior or self-reported behavior change, right? So that is squishy. And sometimes what we do in the models, and I'm fairly new to this too, is we kind of attenuate or we shrink that. We might take half of it and do a calculation, right? Because we can't assume that everybody's going to do the things they say they're going to do or they say they've done. So it is squishy. However, there's going to be cases where you have perhaps more objective data that you can work with that helps you and increases, the value of the model. The thing is that kind of the principles that are applied here seem to come from health economics and outcomes research, HEOR as it's referred to, and I know that Katie has a lot of experience with this and could share some thoughts too.
Well, thanks, guys. Yeah, I think it's how do we give guidance about the most conservative approach if there are some of the squishy leaps that we're making and you don't have the objective practice data to then extrapolate into costs. So like would we say it's better to use self-reported performance changes rather than intended, and maybe to say don't use intended. But then there's that whole idea of sample bias again. Do the people who report their changes back to you, are they more likely to have changes? I think there's a lot of work to be done in understanding that question there is, are they representative, the ones who do report back, or are they not? So that until we kind of have more details there, then I think we should definitely go the most conservative route. And is that cutting it in half, or is it taking the minimum?
I don't know. I don't know what it is, but the beauty of these models is that you can plug in a conservative estimate and a more liberal estimate and report those in a variety of ways. And we need to critique each other on these, just like we're trying to do here. We need to look at them and say, well, what about this? Did you think about this? Not an effort to discount anybody's work, but just to improve it. And hopefully over time, our effectiveness can increase and we can understand the costs and cost savings of what we're doing.
Perfect summary.
Katie, while you were talking there, it kind of made me think about the pairing of data too. Like if you are asking people for intent to change and the follow-up of did you make changes, if you have that data paired, which becomes even harder on follow-up studies, I understand, but like you can then start to develop an understanding of the accuracy with which people make predictions, right? So you say, okay, well, this is what they told me they were going to do, and this is what they told me they did 6 weeks later. How does that match up, right? To kind of get back to like, well, what sorts of adjustments should we be making to things like intent to change metrics?
Great.
Oh, so I've got 2 cleanup questions I think we can address pretty quickly in the chat. Derek W., you had one you wanted to add?
I do, but guys, I'm going to wrap this up because I need people to hop over. I think we're still online here, and so I didn't quite work as I thought it was. I thought people would automatically go over, but that didn't quite work. So I'm going to end our broadcast in fairness to the next session.
Of course.
But maybe we can answer them online.
Will do.
And put in some answers, and we'll do it that way for them. So,
cheers.
All right, everyone, refresh your screens and go on over to the next session. You guys can hold on 1 second. I'm going to end our broadcast.